All right, 1.4. Using the definitions of the trig functions. All right, some important identities. An identity is just meaning like it's an equation. The left side equals the right side, right? Meaning they're identically the same equivalent expression, but might look a little different. That's what an identity is. So first we have what's called the reciprocal identities. We've already used them. Sine of theta was related to its reciprocal, it's cosecant, right? They were reciprocals to each other. So all I have to do is say the reciprocal of sine is 1 over cosecant. Just like I could say the cosecant is the reciprocal of sine, 1 over sine. Cosine, 1 over secant. Secant is 1 over cosine. Tangent is 1 over cotangent. Whereas cotangent is 1 over tangent. All right, so these identities are really, really useful. You're going to see when we get to one section called establishing identities, how to make substitutions of more complicated trig functions to basic, to get them back into their basic trig functions. So if you see cosecant, we can change it into terms of sines or secants in terms of cosines. All right, the signs of function values. One of these days I'll be able to draw a straight line. All right, we got quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Just remember this little mnemonic. It's really easy. All students take calculus. Quadrant 1, everything is positive. All is positive. Think about it too, because your x is positive, your y is positive, or is always positive, right? In quadrant 2, the S stands for sine. Okay. Sine of theta is positive. If sine is positive, its reciprocal is positive too, right? So also its reciprocal cosecant. Again, the coordinates, x would be negative, y would be positive, right? Everything else is negative. And we get to quadrant 3. T stands for tangent. So tangent of theta is positive and its reciprocal cotangent, right? Everything else negative. And then cosine for C. Cosine of theta is positive and it's reciprocal. Everything else negative. So all students take calculus. But I like to think of it as sines and cosines. Sines is everything either top two or the bottom. Positive is up there. Here for some cosines, I'm going to place a positive on the right. Right. So sines of theta up and down, cosines left. So I'll narrow down to two of the quadrants, and then you can go further, get more information, narrow it down to a single quadrant. But all the trig function values, like we saw earlier, we know some of them can be positive, some can be negative, those things, right? So that's when you get one of them, it's easy to figure out the remaining. So if I say 300 degrees, is sine positive or negative 300 degrees? You can always just use a calculator too to see positive or negative, but sine is going to be negative because 300 degrees was in positive. All right. Also note that if I have a triangle or just an angle in standard position, let's do that. There's theta. This is y, this is x, this is r. R is always the bigger side, right? So if you go back and look at your notes of all those trig function values that we calculated, notice something unique about sines and cosines. The r is the bigger number is always in the bottom. The x or the y is always smaller than r, always, right? That's a leg of a triangle. So this is always going to be less than 1 or greater than -1, right? Let's put it this way. There's always has to be between -1 and +1. Same thing for cosine, because the r is in the bottom, right? So between -1 and +1. Now tangent, that could be anything. So tangent can be any real number. So from -infinity to +infinity. So if I say the sine of theta is equal to 2.5, is this possible? Well, even if you don't remember what their outputs can be, put it in the calculator. The sine of, wait, you just take the sine of any angle. Sine of 60, inner. Oh, that's a number less than 1. The sine of -5698, inner. Positive 88.88. So you can kind of figure out that nothing is generating a number bigger than 1, right? So this can't be possible. No, won't work. That's greater than 1. All right, their reciprocals, I'm not going to mention those right now. We'll look at that later on when we start looking at the graphs, how much easier it is to figure out what their outputs would be than just trying to memorize all this. All right, let's say given one trig function, you can always find the remaining trig functions. Okay? Just kind of need to know where your angle lies. That has to be told to you. Okay? If not, you have to have enough information to be able to figure that out. Okay? Let's say, suppose theta is in quadrant 1, 2 that is, and sine of theta is equal to 2/3. Sine is positive in quadrant 2, so we know that. If they didn't tell me if we were in quadrant 2 and they just gave me sine as 2/3, I have to be either in quadrant 1 or quadrant 2. Then I have to be given a little bit more information to be able to figure out exactly what quadrant I'm in. Find the remaining trig functions values. So in terms of x, y's, and r, sine is y over r, right? So we know our y value and our r value. We just need to know the x value to figure out the remaining trig functions. Well, use your Pythagorean theorem that r squared is equal to x squared plus y squared. 3 squared is equal to x squared plus 2 squared. 9. 4. X squared is 5. Take square root. Don't forget the plus and the minus when using the square root method, right? Solve for x. But now we need to make a choice. Is x positive or negative? Well, we're in quadrant 2. X is negative, right? All right, so from here, it's really simple. Now we can just fill in the blanks in a sense. Cosine x over r. Our x is a negative square root of 5. Our r is a 3. Tangent y over x. And again, like I said, this may or may not be your first time seeing the relationships of x, y's, and r's, but you're going to get the hang of it so much by doing this. Okay? You're going to just know it, memorize it really quickly. So y in this case was a 2, x is a negative square root of 5. Let's rationalize it. That's going to be a negative 2 square roots of 5 all over 5. Now our reciprocals, cosecant, flipping 2/3 gives us 3/2. Secant, flipping right here, we have a negative 3 over the square root of 5 and rationalize it. Negative 3 square roots of 5 all over 5. And lastly, cotangent. If I flip right here, 2 over the negative square root of 5 is negative square root of 5 over 2. All right, so we talked about the reciprocal identities, very, very useful. The next one are called the Pythagorean identities. All right, the very first one, most people, if you've had any basic trigonometry, you recall this. The sine squared plus the cosine squared is equal to 1. That comes from the Pythagorean theorem. Let's see. This is x, that's y. This is r. Let's say theta is right there. And let's see, if I say the sine of theta is y over r. The cosine of theta is x over r. So sine squared of theta is squaring this number. So that's y over r all squared. Same with cosine squared. It is x over r all squared. And we know that x squared plus y squared is r squared, right? So if I say sine squared, y over r all squared, plus x over r all squared is equal to, this has to be equal to 1. This is y squared over r squared plus x squared over r squared equals 1, which is y squared plus x squared all over r squared equals 1. And this holds true. X squared plus y squared cross multiplying is r squared. So it just kind of proves that sine squared plus cosine squared of those thetas does equal 1. So any trig function value that you get when you see the notation, sine squared, cosine squared, its value is always squared. Not the sine is being squared, the trig function value is being squared. The same way as saying sine of theta all squared is the same as sine squared theta, just different notations. So this is not the angle being squared, it's the value being squared. All right, so that's part 1 of your Pythagorean identity. Second part, we'll leave for next time.